I'd like to talk about rewriting this polar equation in rectangular form. Remember, when we're talking about equations that are polar and rectangular, here are some common relationships that we use. X equals r cosine theta and y equals r sine theta, and x squared plus y squared equals r squared. Remember, the goal when we're going from polar form to rectangular form is to get rid of the r's and thetas and get it written with x's and y's. That's our task. So I'm looking at this equation, and as we often do, let's multiply by the denominator and clear out our fractions. So let's multiply by 1 minus sine theta on both sides of the equation and see where that takes us. Now when we do that, we can distribute the r, so we'll have r minus r sine theta equals, and on the right hand side these cancel and we just have 9. Now I hope that r sine theta jumps out at you, because we know r sine theta is equal to y, so let's make that substitution. So we have r minus y equals 9. So I now just need to take care of that r. I don't have a nice substitution for r. I do have a nice substitution for r squared, but if I were to square both sides of the equation as it looks right now, over on this side I'd be squaring the binomial and I'd have a y squared and an negative 2ry. It'd be a little bit nicer if I added y to both sides so that the r would be by itself on the left. And then when I squared both sides, I would just have r squared on the left and some terms that involve y on the right. So let's do that. Let's square the r and square the y plus 9. And when I do that, I get r squared equals, and on the right hand side we'll square that binomial. We have y squared plus 18y plus 81. But now we have our r squared, and we know r squared equals x squared plus y squared. Let's make that substitution. And now notice we have a y squared on both sides. Let's subtract y squared. And we have this equation. X squared equals 18y plus 81. I hope you recognize it now as a parabola. I wouldn't have expected you at this point to have recognized this as the equation of a parabola, but in fact it was. And now in rectangular form we can see it. Now, since we know it's a parabola, let's take another step or two and write it in standard form by factoring out the coefficient of y. So we'd have x squared equals 18 times. Now, let's see, if I'm factoring out 18 from that 81, that's really 81/18ths, right? Notice 18 times 81 over 18, the 18s cancel and we get our 81. But that's reducible, so I would never present that as my answer. So I have x squared equals 18 times y plus, and 9 goes into both of those, 9/2. And now I have this equation in rectangular form. And we even have the rectangular equation in standard form down here. Let's do one more. The directions are still the same. Rewrite the equation in rectangular form. And let's let the equation be this. R equals 4 over 3 plus cosine theta. Now notice it kind of looks like this one. We have a cosine instead of a sine. We have a plus instead of a minus, but we have a denominator there. Let's see if we get another parabola. So I'm going to do the same thing that we did on the previous one. Let's multiply by 3 plus cosine theta to clear out the fractions. So 3 plus cosine theta, and on the left-hand side, 3 plus cosine theta. So let's distribute the r. So we have 3r plus r cosine theta on the left. And on the right-hand side, the 3 plus cosine thetas just cancel. And we have 4. This time we have an r cosine theta. I hope you recognize that as an x. So we'll make the substitution. So 3r plus x equals 4. Don't forget our goal. Our goal is to get this written in rectangular form. So we need to get rid of this r. We want the equation in terms of x's and y's. Again, much like the previous problem, I don't have a nice substitution for r, but I wish I had an r squared. And I don't want to square both sides as it looks right now because I would have to square this binomial. And if you squared this binomial, it wouldn't look so nice. You'd have an r squared and an r in it. So we want to isolate this term with the 3r, isolate the 3r. So let's subtract x. Now that we have the term isolated that contains the r, let's square both sides. So on the left-hand side, I have 9r squared. And on the right-hand side, again, I multiply out my binomial or square my binomial, and I would get 16 minus 8x plus x squared. Let's make a substitution for that r squared. We know r squared is x squared plus y squared, so we'll do that carefully. Make sure you don't lose those parentheses because 9 is being multiplied by x squared plus y squared. We're going to have to make sure we distribute in a moment. I just have a personal preference for having that x squared first, so I'm just going to rearrange the order. I just prefer it that way. So now my equation becomes 9x squared plus 9y squared equals x squared minus 8x plus 16. And I hope you now recognize it again as a conic section, but which one? Let's set it equal to 0 and take a look. So we'll subtract x squared. We have the 9y squared still. We'll add 8x, and I'm going to subtract 16. And we just have it in this general form where this equation is set equal to 0. Do you recognize what it is? The signs on the x squared term and the y squared term are the same. But the values are different, so we don't have a circle, but this one is an ellipse. Remember, if it were a hyperbola, the signs would be different on the x squared and the y squared. And as in the previous problem where we had a parabola, you would only have a y squared or only have an x squared. So we do have an ellipse this time. Now, it depends on what the directions are for a problem that you're working on. The directions that I gave you were just to rewrite in rectangular form. It's in rectangular form, but I just like to practice putting it in standard form. So let's just continue and put this in standard form for an ellipse so that the center of the ellipse is looking at us and we would be able to graph it if need be. So let's continue. Remember, the standard form for an ellipse is something like x minus h squared over a squared plus y minus k squared over b squared equals 1. We want this equation to look like this. And the a squared and the b squared could be switched. But the main point is we need to complete the square with respect to x and y if we don't already have a perfect square. Notice with respect to the x's, I am going to need to complete the square because I have an x squared and an x. I have a y squared but no y to the first power, so I'm not going to need to complete the square with respect to y at all. But I am going to need a new piece of paper because it's going to take me a few steps to get there. So let's do that. Let's move this up. And I'm going to copy the equation down again. It is 8x squared plus 9y squared plus 8x minus 16 equals 0. And we're just going to practice writing this in standard form. So I put the x's together. I have my y squared still here. And the constant doesn't need to remain on this left side. We'll put it on the right side. Again, don't lose sight of our goal. Our goal is to get it to look like this. So let's continue. To complete the square, I need to factor out the 8. Remember, your coefficient of your quadratic term needs to look like a 1, so I'm going to factor out that 8. So I have an x squared. So in the parentheses, notice there's just a 1x squared, and that's the point, plus x. And I have plus 9y squared equals 16. Now remember, to complete the square, I take half of 1 is 1/2, and 1/2 squared is a quarter. So I need to add 1/4 right here. But notice I didn't actually change the left-hand side by a quarter. I added a quarter inside the parentheses. This 8 is being multiplied by that 1/4, so I actually added 2 to the left-hand side. So I need to make sure I add 2 to the right-hand side as well. So now I have 8 times x plus, it was 1/2 that was squared to give us that quarter. And then I have plus 9y squared equals 18. Let me show you again, remind you about standard form for the parabola, or excuse me, the ellipse. I want it to look like this. I need a 1 over here. So let's divide by 18. Divide by 18. I can do some reducing. Let's see, I have 2 going into both of those. So I would have 4 times x plus 1/2 squared over 9. I'm going to do some reducing here too. Y squared over 2 equals 1. And I am almost there. Here it is again, standard form. Look at this. Coefficient here is a 1 in order for us to see an a squared down here. 1 here. So I can't stop right here. I'm going to take care of this 4. Now you can think of it a couple different ways. One is you can look at this quantity of x plus 1/2 squared and think, hey, it's being multiplied by 4/9. I know that multiplying by 4/9 is equivalent to dividing by 9/4. And you can get there that way. Or you can think of it this way. Divide the numerator by 4 and divide the denominator by 4. And that's mathematically valid because you're multiplying numerator and denominator each by 1/4. So that gets us the 9/4 down here. We still have an x plus 1/2 squared in the numerator. I still have a y squared over 2 equals 1. And here's our ellipse as a rectangular equation in standard form. So let's come back to the beginning of this problem. Here's how we started. We started with an equation that looked like this. And now we know that it is, in fact, an ellipse. Here's how it looked when we converted it to rectangular form. And I do want to point out, it was an ellipse in polar form. Here was a parabola in polar form, notice they look very similar, right? That's the way conic sections can look in polar form. And there is another way you can analyze those equations so that you could graph those conic sections. But that will be a topic of another video.